Okay, good afternoon. So we continue our lesson with the quadratic function, this third session about it. So the same question. The reason that I bring it up again is because this factor is not 1 this time. We've learned what happens if the factor is 1. We also learned what happens if the factor is -1, having a minus sign here. But this is essentially very similar. The only bad thing is that you have to work with fractions. That's it. So what we do first, the same questions. The domain is always R, so don't forget about the domain. So I want to answer what is the range, what is the turning point, and the same questions. What is the symmetry line? Okay, so now you have a lot of experience from the previous lessons as well, so you have to be a little bit creative to come up with the idea yourself. I don't think it is hard. So if you have a number here, what you do, you factor that number out regardless of if the numbers are divisible by that number or not. Okay, so we take the factor out. Here this is divisible, I am lucky, so it becomes x squared. This is also divisible, so, but this one is not divisible, so write with fractions. Of course, in this case, you can write 3.5 because that's exact value, but you have to learn working with fractions. Let us say this is 3. Then when I factor 3 out, it becomes 7 over 3. By the way, do you understand that is correct? Because if I multiply this back, I will get this one, and 2 times 7 over 2 becomes 7. And then again, concentrate on these two pieces. Ask yourself what I need to make the first two pieces a complete square. Which number is needed? So you copy and paste this one. You copy and paste this one. You copy and paste this one here. But then from the experience you have, you know that you need a number so that together they become a complete square. What that number is? No, this number. 1. Yes? I told you this number divided by 2 squared. This number divided by 2 is 1 squared. But I added 1. I cannot just add 1 out of blue there. So I have to take it off as well. Okay, and then what I do, I would write that this is 2. This I can combine it as x plus 1 to the power of 2. But these two should be combined now. I have -1 plus 7 over 2. So I take the common denominator 2, so it becomes -2. This is 7 over 2. When I add them, what I get 5 over 2. So this is nothing except plus 5 over 2. And when you finished completing a square, multiply this number back. Exactly as I did with the minus sign. Do you remember? I put the minus sign out. When I did my job, I multiplied the minus sign back. That's the same story. So I multiplied 2 back. Then it becomes 5 again. So if you don't mind, let me write this, and I want to ask your opinion because the rest of it is essentially you should be able to answer me. So y is equal to 2 multiplied by x plus 1 squared, but plus an extra 5. Okay, can you tell me what is the range? Again, you see that this number to the power of 2 is non-negative. If I have a non-negative number multiplied by 2, it remains non-negative, essentially positive. If I add a positive number to 5, I go beyond 5. So y is greater than or equal to 5. Exactly as, so this 2 here doesn't change anything there. Okay, so if I ask you what the range is y greater than or equal to 5. And if I ask you what is the turning point, so the turning point, let me use the word extreme point this time. Last session I always said turning point. Let us work with the word extreme here as well. So the extreme point is what? Is two numbers. I have to write two numbers, the y coordinate, the x coordinate. Do you remember what is the y coordinate? 5, that number that you got there for the range. But what is the x coordinate? The x coordinate is the number for which you get 5. If I want to get 5 for y, I have to get rid of this completely. Which number allows me to get rid of this? -1. Because if I put -1 here, this becomes 0 and vanishes. This is -1. So that is the extreme point. What type of extreme point is this? Minimum or maximum? Minimum. So this becomes the minimum point. Could you predict this is minimum point? Yes, because I told you, memorize this. You can draw this picture. If you have this scenario, A is positive. If you have this scenario, A is negative. It is good to have this picture in mind. So here A is this one, positive, so I should have this scenario. It should be a minimum. Okay, if I ask you what is the equation of the symmetry line? What is the equation of symmetry line? The symmetry line. The symmetry line is a vertical line that passes through the turning point. So the x coordinate is -1, so x becomes -1. Yes? And if I ask you what are the zeros, to zeros, I need to put the equation equal to 0. By the way, it doesn't matter. You can put that equation equal to 0 or not. But let us start from scratch. If I put this one equal to 0, then you see that there are no roots. Yes? Because if I put this equal to 0, first I have to calculate the discriminant. Discriminant is b squared minus 4ac. This is to power 2, 16, minus 4 times 2 is 8, times that is minus 56, so it's minus 4d. Because this is negative, there are no roots. So it means that this function does not have any zeros at all. So no zeros. What does it mean? Do you remember what is the meaning of a zero geometrically? From graphical point of view, what was the meaning of zeros from graphical point of view? The zero is a point of intersection of the graph with the x-axis. So when you say that there are no zeros, it means that when you draw the graph of the function, it is in a way that it does not intersect the x-axis at all. And that is reasonable. Why? Because you yourself find that the minimum is how much? The minimum height. The minimum height is 5. So the minimum height is 5. So it means that the graph will be higher than 5. So there is no way that the graph can intersect the x-axis. So it was also predictable without calculations because the minimum is 5. For example, if the maximum is -2, do you think there are zeros for the function? The maximum is -2. If the maximum is -2, it means this is -2. The highest point is here. Okay? So it means that the graph should go down. And if it goes down, there is no chance for the graph to intersect the x-axis. Okay? Yes?
Are there any equations that do not intersect with the y-axis?
Yes, exactly that one. So if I ask GeoGebra to draw this, you will see that it will not intersect.
I mean with the y-axis, straight
Yes, that also is possible. For example, the function y equals to a square root of x minus 1. This will not intersect the y-axis. This will, yes, this will not. The graph of this function is like this. Yeah, it is possible for any case, yeah. Okay, so is that understandable? Yes or no?
Yes.
Okay. So now I want to give you one more, but I want to make it negative, and I want to wait for you. So we covered everything. It doesn't matter which coefficient you have here. Okay, so let me write this one. Let me write f of x equals to, this time let me write minus 3x squared. I want to make it a little bit hard because of the calculations, okay? But so be careful. try to do it with hand, okay? So I would write 2x, and then I would write here minus 4. This is harder because I intentionally chose the numbers in a way that it generates fractions. But except for that, you shouldn't have any problems. No, the zeros are the points of intersection of the graph with the x-axis. But when you say the minimum height is 5, so it means the rest of the graph lies above the height 5. That's the meaning of minimum. So there is no chance for the graph to go and pump back down, you know? Because if you want to intersect with the x-axis, you have to reach to level 0. But you say that the minimum is 5, so there is no way to come down. And if you draw this, I will do this with GeoGebra after we are done. If you draw this, you will see that it really goes from 5 upwards, and there is no chance for it to come back and intersect. Okay, so what we should do? The first thing I told you, whatever this number is, you should take it off, out. So what happens? I get minus 3 out. Here I don't have any problems. But what should I write for the middle one and the last one? What should I write? You need to write something that when you multiply minus 3 in, it gives you 2x. Minus 2 over 3x. Do you agree? Because if I multiply minus 3 back, first of all, minus times minus becomes positive, and then 3 times 2/3 becomes 2. So that's correct. What happens to 4? Plus 4 over 3. Why plus? Because after being multiplied, I want to get minus 4 back. Minus times positive becomes minus. 3 times 4 over 3 becomes 4. I told you that this is a little bit computationally involved, but that problem is simple. So do you remember I copy and paste this one, I copy and paste these two parts, I copy and paste the last one as well. Then I ask myself, what should I add here? And I told you the rule of thumb. The rule of thumb is whatever this number is divided by 2 and raise it to power 2. So hopefully, if I ask you what happens if I divide this by 2, what happens? 1 over 3. And then raise it to power 2. 1 over 9. So the number that you have to add is 1 over 9. But you cannot just add 1 over 9 because 1 over 9 was not there. You can do it with the condition that you take it off again. And then what you do, you write minus 3, and this is what? These 3 can be combined into one complete square. What is that? This is the minus version, 1 over 3, exactly. And this is your duty to combine them. So you go to a scratch paper, for example, you have minus 1 over 9, and then you have 4 over 3. So you write minus 1 over 9. 4 over 3, I want to make the denominator the same, so I rescale it by 3. And then I add them. It becomes 11 over 9. And then what I do, I multiply minus 3 in. So if you multiply minus 3 in, I will, so multiply, it becomes minus 3, x minus 1/3 to the power of 2. Can you do it in your head? Minus 3 times 11 over 9. 9 can be simplified with this 3, 3, and 1. So it becomes minus 11 over 3. So let me write it here in front of your eyes. So the y value is equal to that expression. Okay, now I want to hear your opinion. So, is there any minimum or maximum in this case? Of course, the rule of thumb I told you, if A is negative, definitely you should have a maximum. And here A is negative, so it should be a maximum. So if you get confused, you have to use your memory here. But if you are not confused, you understand that there is no maximum, there is no minimum for this, you know? Because, for example, let me choose x very, very big. then this expression becomes very big, but when I multiply it by minus 9, it becomes very negative. So I can go down and down as much as I increase x. So there is no bottom for this well, yes? You can just go with head into it, yes? So that's one interpretation. Another thing is that this expression is positive because of power of 2. When you multiply it by negative, it becomes a negative. So this is less than or equal to minus 1 over 3. Because minus 1 over 3 is a fixed point. You are adding a negative value to your value. So you go below that value. You don't go above that value. Yes? So y is less than or equal to minus 11. So if I ask minus 11 over 3. So if I ask you what the range is, what is the range? Y less than or equal to minus 11 over. Yes? Is that right? This number is a negative number. Why? You might say, Baba, if you don't know x, how do you say this is negative? I would say that I don't need to know x. X, whatever it is, this number is either positive, 0, or negative. Regardless of that, I am raising it to power 2, so definitely it becomes positive. And when this is positive, I multiply it by minus number, it becomes negative. So this expression, even if I don't know its exact value, I know it is negative. Minus 11 over 3 is a fixed number. I am adding a negative number to my number. So I go below that number. I cannot go above that number by adding a negative number. So this means that y cannot go beyond this. It should go below this. So y is less than or equal to this. When you say y is less than or equal, it means the maximum threshold for y is minus 11 over 3, because y is always less than that value. So that's the maximum level. Yes? Okay, so then if I ask you what is the extreme point? What is the extreme point? This y value is the here, and then I need to see which value causes this. I mean, what x causes y to be exactly this number? Which x will give me that? If I want to have exactly equality, I have to be able to get rid of this. There is only one way to get rid of this, and that is choosing x to be a third. So that is 1/3. But this extreme point or the turning point is of what type? We learned here, this is of maximum time. So that is another name for it in this case is the max point. If I ask you, what is the symmetry line? What is the symmetry line?
1/3.
1
X.
x, yes, you have to write x equals to y. This is a have to. If you just write 1/3, that is not acceptable. So that is the symmetry line, the equation of the symmetry line. And if I ask you what about zeros, you have to calculate the zeros. But do you think there is any zeros for this? For zeros, you can put this equal to 0, use ABC formula to see if there is any zeros or not. But in this case, if you understand what is going on and imagine it in your head, you understand there are no zeros. Do you agree? Because minus 11 over 3 is a negative number, and you are telling me that is the maximum height. So the maximum height is still below the x-axis. So there is no way that the branches of my graph will intersect that one. So it's clear that there are no zeros here. Yes? Okay. Now there is one part, I didn't talk about the sketching of the graph, but I want to say something because I saw in some of the exercises this is also going on, and I want you to know that. Okay, so this is important. The sketching, I hope that you understand what to do. Of course, it might be a little bit messy, find the points and connect them. But there is another important thing I saw in the book. I want you to know about that as well, and that is the shifting of the graph, you know. And mainly I want to do it with GeoGebra, but I want to get a feeling about this. For example, if I ask you, this is one of the pictures I want you to have in mind. So I hope that you remember how y equals to x squared looks like. This is the simplest quadratic function ever, yes? Do you remember? It was something like this. okay, more or less. Of course, this is not precise at all, but this is a parable. This looks like that. Now, I want you to understand, if I give you this graph, and I ask you what is the graph of this one, or what is the graph of this one, or what is the graph of this one, or what is the graph of this one. This is important. I want you to understand the relation between the graph of these new functions and the graph of the function that you already have. By the way, what I am talking about is not related to this function. It is completely generic. If you have a function, what happens if you have the graph of any function? What happens if you add one unit to the function? If you add negative unit, if you subtract one unit from the function? Or what happens if you add one unit to x? You see, I took x off and put x plus 1 instead. And then I took x off, I put x minus 1 instead. And there is a very nice relation between them. I want you to understand them. That is a shift. Okay? So if you add one unit to the function, the graph of the function will be shifted one unit upward. And that is clear. Why? Because when I add one unit to x squared, what I am adding, so the y value is the old y value plus one unit. So the y values for this function are correspondingly one unit more and than the y values of this function. So what does it mean? It means every y value will increase by one unit. So the net effect will be that this graph, considered as a rigid object, like a ball, it seems that you are shifting this ball one unit upwards. And if I write x squared minus 1, what do you expect? That we expect shifted one unit upward. So this, I call it natural. The counterintuitive one is what happens when I add x1 to x, not to the function. Okay, can you guess? So for example, I cannot draw good pictures, but if you tell me, for example, I give you this graph and I ask you to draw this graph, then you know that you go one unit upward and copy and paste this. I cannot, of course, do it exactly, but pretend that this is the same thing shifted one unit upward. And then for the other one, I can go one unit downward and then copy and paste it again. Yes? So this is the effect of adding or subtracting from the whole function. But what do you think will happen if here you see I am not adding one unit here, I am adding one unit to the x only. So I am taking x off, I will have this empty space, and in the empty space I am writing this. Okay? So what do you think will happen? The x value, okay, let us ask.
Maybe it moves like horizontally.
Yes, it moves horizontally.
But like if it's plus 1, then it moves like to the
Yes?
right, to the right side, and if it's minus 1, it moves to the left side.
Yes?
Yeah, it moves to the right and it's off.
No, why up then?
Because at the end it's plus 1.
No. I'm talking about this one only.
So x squared plus 2x plus 1 the plus 1.
No, that is, I understand what you are saying. You are just raising it to power 2. You see, this is not easy at all. So you cannot say I am adding 2x to it. I understand what you are saying. That's correct. But this is not easy to imagine what happens. If I have x squared plus 1, and if I add 2x to it, because 2x is not fixed, I don't know what's happening. You know? But here, 1 is, so what Shah said is 99% correct, and that is usually the common mistake people do. That's why I'm saying this one is a little bit counterintuitive. So what you said, if I understood you correctly, you said this one will be shifted horizontally, one unit to the right.
Yeah.
But that is the opposite. It is one unit to the left. It's counterintuitive. I try to convince you about that, but then you need to remember it. And this one is one unit horizontal, but not to the left. Even though this is negative, it goes to the right. Okay, first of all, let me convince you first by drawing the graph here. So let us just put the very simple one, y equals to x to the power of 2. This is the original function. And then let me type this one, x to the power of 2 and plus 1. So you see, let me show it for you here. So it is shifted 1 unit upward. Okay, so I don't know why GeoGebra doesn't change the colors by itself. Let us change the color. Okay. And now let us say that y equals to x to the power of 2 minus 1. And then let me change the color as well here. So for example, a different color. So let us say green. Okay, so you see the green one is the black one shifted 1 unit down. The red one is the black one shifted 1 unit up. Okay, now let us take these two off. And now let us type this one. So now Shah, you can check it yourself. So I will type the first one, x plus 1 to the power of 2. But then the shift is not to the right, it is to the left.
Because, this is because like the minimum point is minus 1, right?
Exactly. Exactly. Yes, that's good. That's a very good way of saying it. Let me change the color. Okay, so you see this color is this one, and this is not the black one shifted 1 unit to the right. It is the black one shifted 1 unit to the left. Okay, and if I change the sign here to minus, it will automatically shift to the right. You see, now this is shift to the right. So remember this. If I add 1 unit to the whole function, okay, it will go up and down. If I add a unit to the whole function, it goes up and down, and it is natural. Yes, natural means that if you add, it goes upward. If you subtract, it goes downward. But if I change x to x plus a number, if that number is positive, the shift is horizontal but not to the right, to the left. And if it is negative, it is to the right, not to the left. So, and what Shah said is very good, because he said that, okay, if I ask you, by the way, if I ask you, let me ask you some questions, test your understanding. So what is the turning point here for y equals to x squared? You can also see it on the picture.
0, 0, 0.
So 0, 0. That's the turning point. You don't need anything, okay? But if I ask you, what is the turning point here?
Minus.
So do you remember? Let me ask you this question. What is the range of this function? What is the range of this function? Greater than or equal to 0. Yes? Why? Do I know x? No. What I know is that this is some number to power 2. So that number is non-negative. So the range is y greater than or equal to 0. Okay, when do I, so if I ask you what is the minimum point, the y value is 0. But what is the x value? The x value is the x responsible for this minimum value. What x is responsible for that? Minus 1. So this is this is, by the way, this is called vertex if it's a parabola, or the turning point. So you see exactly what you described is correct, because the turning point is not 1 and 0. If it were 1 and 0, the shift was to the right, but you see it is minus 1 and 0, so that the shift should be to the left. Is that right? I can combine these effects. For example, what do you think will happen here? For example, I give you that function, y equals to x squared. This is very famous, you remember, this is the blue one. And then, for example, you want to draw the graph of this, or imagine the graph of this. So how do you imagine this graph now? Those two things are happening simultaneously. A 3 is added to the whole function, but 2 is subtracted only from the x part. So what happens, do you think? Yes?
Right, yeah, it would move like 2 to the right and 3 up.
3 of them. Yes? Simultaneously. So because you can say that like this. You can say that I start from here. Do this, by the way, these kind of things are called transformations. You are transforming the graph of one function to another graph. So y equals to x squared. Let me change x to x minus 2. What happens? It becomes x minus 2. But I told you, what is the effect of this kind of transformation? X is changed, so the shift should be horizontal. How many units? 2 units. Which direction? To the right, because this is negative. So this transformation will shift my graph 2 units to the right. And then I do this transformation. I add 1 y to y plus 3. So I add 3 units. Then I will get this one. But what is the effect of this? It is clear. You are changing x to y. You are changing y to y plus 3. So you are going 3 units up. So if I want to draw it, it is not that probably easy, but we will do it using GeoGebra. First, I go 2 units to the right. Let us say that this is 2 units to the right. So this is the here. The drawing is not that easy, but you can imagine that. And then this dotted line should be shifted 3 units upward. So it comes here. Yes? So let me just draw it using GeoGebra. That's a nicer picture. So I go to GeoGebra here. Let me take these off. And let me put this, this is needed. Let us keep it. And then let me type that function. Y equals to x minus 3, no, minus 2 squared. So you see, let me change the color here. So what is happening? Okay, so for the time being, I am shifting x minus 2 squared is the shift of the black one 2 units to the right. Do you feel that? Yes? And now I take this function and add what? 3 to it. So it becomes x minus 2, which is the old one yet. That's the same thing, but plus 3 units. And let me change the color here as well. So for example, let us just take it this one. So what you see is the purple one. So here, I started from the black, shifted it 2 units to the right, and then shifted it 3 units upward. I could do this the other way around, yes? Instead of shifting to the right and then above, I could shift above first and then to the right. The answer will be the same. And that is also understandable here. Why? Because instead of doing this first, what I will do that shift first, y to y plus 3. Then what do I get? I get y equals to x squared plus 3. And then I do this shift, x to x minus 2. Then it becomes y equals to x minus 2 to the power of 2 plus 3. So you see, I end up the same place. So it doesn't matter if you do the shift horizontally first and then vertically or the other way around, the answers are the same. If these two operations, these two shifts, can be interchanged, in mathematics we say that these transformations are commutable. Commutable, it means that you can replace the order without affecting the result. Here I have the horizontal shift followed by a vertical shift. I got this function. Here I have the vertical shift first followed by a horizontal shift. I got the same function. So even though I did it in different order, but the results are the same. Whenever this happens, we say in mathematics these operations are commutable. They can be commuted, yes?
Is it important that we know the rules?
No, it's better if you want, if you are, no, I will not ask that. But I just want to give you as an extra information. Okay, but one question is that, because I might be, that's also some question. What do you think happens if I multiply? So for example, do you have any idea what will happen? So let us say that I multiply x squared by a factor of 2. How do you think this will affect this blue original curve? This blue original curve is the graph of y equals to x squared. Okay? And I take that function, multiply it by 2. What happens? Let me ask Ismail first.
Wider.
So you say wider. Okay, but what do you say?
I will also say wider.
Wider? Narrower.
Narrower.
Yes? So be careful. Why? I want you to understand yourself, because what is happening? So you see you have two functions, this one and that one. When I say I multiply x squared by 2, it means that the new y is 2 times larger than the old y. Is that right? So what does it mean? It means, for example, if you have this point on this graph, this point will jump to you. So let us say this is 1 unit. So let us say this point is on this graph. The corresponding point on this graph will be with the same x, but with which height? 2 times larger. So it will go here. So this point will jump here. Yes? So every point that you have here, every point so will jump 2 units up. Yes? So the net effect is this. So it seems that it is becoming more narrow, not wider. Let me ask you, if I want to make it wider, what do you do? Yeah, not minus. Minus doesn't have that effect. But 0.5. So what happens? If I ask you if y equals to 0, 5x squared, then it becomes wider. Why? Because this point will jump where? This point has height 1 in this one. Now it becomes what? 1/2. It becomes here. So this means that this becomes wider. So do you understand? So if you multiply by a number bigger than 1, you are not making it wider. This is counterintuitive. You are making it steeper, narrower. But if you are multiplying by a number smaller than 1, you are making it wider. Okay? So for example, I don't know, you can ask what do you expect for this graph? I don't know how do you want to think about it. For example, I would say that I have this function. What do? I shift it 1 unit to the right. Yes, it becomes this function. And then I multiply it by 2, so I make it steeper by a factor of 2, and then I shift it 1 unit upward. So it becomes narrower and shifted 1 unit to the right, 1 unit upward. So let us just do that to see what happens. So if I go back here, so let me clean these two. So this is the standard function. That function I want to write. So I would type y equals to, first of all, let us check it very simple. 2x squared. I want you to feel this is becoming more narrow. Yes, this is becoming more narrow. Let me change the color. So here, this one, this red one, is 2 times the black one. Do you see why? Because you see this point here, let me change this to this pen. So this point you see here has height 1. Now it has moved to height 2. For example, this point has, what is the height of this point? 4. It has moved to height 8. So you see that's why it becomes narrow. So let me immediately change this by typing 0.5. So I would type y equals to 0.5 x squared, and then you see what happens. So let me change the color here as well. So for example, let us make it green. So you see here I am multiplying by 0.5, but I am getting the green one. Green one with respect to the black one is wider. Here I am multiplying the function by 2, which is the red one. The red one with respect to the black one is narrower by the factor of 2. So that is the effect of multiplying. Okay, if I want to continue all of it together, so it will be a shift of 1 unit to the right, 1 unit upward, 1 unit to the right, making it narrower by a factor of 2, and then shifting it upward. Yes? So let us just check that one as well. So I type this here. So y equals to 2 times x minus 1 to the power of 2. Yes, and then plus 1. So, okay, I don't want to keep these things to distract you. Okay, and I don't need the green one, so I can change the color here. Okay, I can choose, okay, there's also one interesting tool here. Let me also show you this. So this one. So you see this one, let us, by the way, you see, go here, translation. Translation is the English word for shift. So this is a more mathematical word. When I say translate, it means I shift. It's not translating from Swedish to English, okay? So that's a translate. Okay, so here, that's a vector. So what I do, I choose this translate, okay? I click on the black one, and I ask GeoGebra to shift it 1 unit to the right. Okay, so, okay, this doesn't work like that. So let me define a vector for you. Do you remember vectors from Math 1C? So I define a vector. This vector is 1 shift to the right. Shift 1 unit to the right. I also need another vector 1 unit above. These are two vectors. This vector shifts everything to the right 1 unit. Do you remember that's the meaning of vectors? And this vector shifts everything 1 unit above. Okay, so now I ask GeoGebra, I go to this instruction, translate means shift by vector. So I click on this and I click on this vector. You see, the black parabola is shifted under the effect of this vector 1 unit to the right. And then what I do, I click on the same thing, but I want to shift it upward. It goes there. And then I have to multiply it by a factor of 2. It becomes a little bit narrow. So these are good things if you want to practice. So you define a vector. So for example, can I design a good question out of it? So let me see. Can you solve this problem? If I give you a function like this, let us combine Math 2C and Math 1C, okay? And I give you a vector, not a horizontal or vertical vector. I give you a vector V. For example, I would say 1 and 2. So what is the effect of this vector? It moves everything 1 unit to the right and 2 units above, okay? So this is a geometrical object. It is a parabola. If I apply this vector on this, I want to shift this curve by this vector. It becomes a new parabola. Imagine that you have a rigid object like the parabola, and you want to move it 1 unit to the right, 2 units up. Can you tell me what will be the equation of that parabola? You should be able to answer that. So that's a good question. I'm combining today's lesson with what we learned in vectors. So I give you this parabola, I give you this vector. I hope that you haven't forgotten this. These are not coordinates. You remember what was the name of these numbers for vectors? This is too much to expect in Sweden. Yes. Do you know my name? Yes? Yes, my name is Babak. So, so these are called components, not coordinates. The difference is too much, okay? That's a big difference. Okay. So can you tell me, yes, do you want to tell me the final answer?
Yes. Yeah.
Okay, tell me.
X minus 1 to the power 2.
No, first of all, when I say write the equation, definitely you have a y. Y equals to what?
X minus 1 to the power 2.
Uh-huh.
Plus 2.
Plus 2, exactly. So might be I don't give you this in the exam. I simplify it in my head. It becomes x squared minus 2x plus 1. It becomes x squared minus 2x plus 3. Might be I give you this question and I give you this vector and I say that, okay, you shift this parabola under the action of this vector. Which one of the options is the correct equation? And I don't give it like that you can guess. I give it like this. So you should be able to write this first and do a scratch work to come up to this answer. Very good. So that is a very good thing to understand. Okay. Now this is one thing that I want to mention. Let me see if there is any question. Well, so let me show you. Can you solve this problem? It's level 3 problem. Okay, but I want you to think about it first yourself. This is related to this lesson. Yes? So the figure on the left shows the graph of this function. So the red curve that you see is the graph of this function. First of all, you should be able to convince yourself why this is a good sketch. Okay, but that is not your duty. The curves on the right have the same form. By this they mean consider this is a rigid object which is moving around when they say the same form. Determine G, H, and P. So exactly like this, this exercise wants you to write an equation for what is their colors, the blue, yellow, and green. Okay? Think about it, because if you solve this, I don't know why they called it level 3 problem, but I think you can manage it, okay? Is the question clear? So this function you see is the graph, is the equation for the red one. They are telling you the green one, the blue one, and the yellow one have exactly the same form as the red one. By seeing the shifts, they want you to write the equations for P, G, and H.
Bobak,
Yes?
are there any graphs that, are there any functions that have two lines that are not connected?
2 lines, what do you mean?
Like that is one line, as usual, one line. Or is there any function that in any way makes it so that there are two separate, like there's a gap between them?
Yes, yes.
Is that
Yes, yes. You're done? Okay, so let us ask your opinion. Okay, I cannot draw them here on the board here, but let us see it here. So concentrate everyone, please, on the green one first. Okay, so compare this red one with the green one, and I want to hear for you. Can you see there are two shifts involved? So what are those shifts? Can you say?
Do I have to say the equation?
No, just give me the shifts first, and then I will go to the board and ask your opinion about that. So how much we have shifted downward?
Like -5.
So it was here first, yes?
Yeah.
And now 1 unit, 2 units, 3 units. Is there any horizontal shift here? No. Okay? So let us go back to the board. So remember this. We shifted 3 units downward. So what do you do now? Can you write me for what is g of x for me?
I wrote like x minus 2 to the power of 2 minus 2. No, I'm sorry. I mean x plus 1 to the power of 2 minus 5.
X plus 1 to the power of
2
minus?
5.
Okay. I'm not sure about it, but why did you make trouble yourself? I mean, you realize that the shift is 3 units down.
Yeah.
So what you need to do, it means that your y should go to y minus 3. This is your y value, and subtract 3 from it. I'm not saying it is wrong. I mean that you are making a little bit life harder for yourself. If I take minus 3 from it, it becomes -4. And now I understand your answer is correct. If you write this, of course, I will give you the full mark. But here you didn't need to write it as a complete square.
It just seems easy.
So this becomes -4. So what I expect you to write is to write this. Yes? So, but if you write this, that's of course correct. Is that clear? Because by comparing those two graphs, I realized that the green one is the red one shifted 3 units down. So it means the new y value is the old y value 3 units less. This is my old y value. I take 3 out of it and I simplify it. That's it. Yes? Okay, now let us go back to the board. Now let us consider the blue one now. The blue one is more interesting. Of course, if you want to do it in that way that Shah did, you can. But you don't have to. I want you to understand what to do. So you compare the blue one here with the red one we have. Do you see any kind of shift here? Because this here was here, yes? Now it has moved 1 unit, 2 units to the, no, 3 units to the right. Okay, now this is more interesting. So I'm interested in h of x. So what should I write for h of x? H of x is the red graph shifted 3 units to the right. Shift 3 units to the right is x changed to what? x should be changed to what? If I want to have a shift horizontally 3 units to the right. So x should be changed with x minus 3. So this tells you, go to your function, take x out and put x minus 3. So I go here, I take x out and I put x minus 3. I take x out and put x minus 3. There is no other x, I copy and paste. So that is my answer. But of course, this answer is not a good answer. It is better to simplify it. I raise it to power 2 minus 6x plus 9. 2 times the first one times the second one, yes. And then 2x minus 6 minus 1. And I simplify, so it becomes x squared minus 4x, and then it goes plus 2. So I prefer to write h of x in this form. Here, if you write this, I will not accept it from you that much. Of course, you will get if there are 3 points, you will get 2 points because of that, but 1 point because of simplification. So here it's important. Might be you have a different scenario, yes? So you can do that as well, but don't write it like this. It is better to write it, because usually it is better not to have pair of brackets. I want to write it in the simplified form. But this is important, that when you realize what the shift is, if the shift is horizontal, go to your function, take all x's out and replace them with the new shift, and then simplify it. Yes? You're not happy, Smile?
Why did you take plus 2 parentheses x minus 3?
No. I told you that. Do you agree that this shift is responsible in this case? Because when you compare the blue one and the red one, you realize that the blue one is the old one, except it is shifted 3 units to the right. 3 units to the right means the shift is horizontal. So if the shift is horizontal, I have to change x. But I want to have it 3 units, so I have 3. But because I want to go to right, I have to write minus 3. It's the counterintuitive part. So I go to my function, take x out, and replace it with x minus 3. Every x. There is one x, take it out, put x minus 3. There is a power of 2 there. And then 2, take x out, put x minus 3. And then this one is the first one squared, 2 times the first one times the second one. The second one is squared, then I multiply 2 in. And then I simplify. Is that right? Yes, we can also check it by GeoGebra, by the way. Let us check it. It doesn't hurt. So you see the function, the original function is y equals to x to the power of 2 what? Plus 2x minus 1. This is the original function. The function I am claiming is this function. Okay, so let me just type it. Y equals to x to the power of 2 minus 4x and then plus 2. Okay, and then let me change the color. I hope that you agree with me. This is done. Yes? Do you agree now?
Yeah.
So that one, the black one, when I typed this in, the black one was the one given in the book. Now when I typed my answer in GeoGebra, I got the red one, which is exactly the black one, but shifted 3 units to the right. Okay? Now let us go back to the problem in the book. Now, can you tell me finally, what is the equation for the yellow one? Okay? So what should I do? So the yellow one, what has happened to the yellow one? Go back again to the red one. If I want to go from the red one to the yellow one, I cannot just go horizontally or only go vertically. I have to combine them. Yes? In which way? I have to go how many units to the right? Can you see?
2.
Yes, I have to go 1 unit, 2 units to the right. Then I have to go 1, 2, 3 upward. Is that right? So 3, remember that. 2 to the right, 3 upwards. Okay? Two to the right means what? I should change x to what? X minus 2. 3 units upward, I have to change the y value to y plus 3. So this is my original y value. Yes? So this is my y value. It doesn't matter in which order you do it. You can add 3 to it first and then do this replacement, or the other way around. Okay, so might be this is not a good idea. Don't think that you have to take y and put y plus 3, okay? It means that the old y plus 3 units. So let me write it like this. New y is equal to the old y plus 3 units. So the old y is this, plus 3 units. This is the new y. I simplify them. And then I want to do this shift, or you can do it the other way around. So the answer is what? I replace every appearance of x with x minus 2. So then I simplify it. I don't leave it like this. So it becomes x to the power of 2 minus 4x plus 4 plus 2x minus 4 plus 2. Then it becomes x squared minus 2x. 4 and 4 are gone, plus 2. So if I haven't done something wrong, this should be the answer. So let us check it by GeoGebra as well. So I go and type this answer now in. So y is equal to x to the power of 2 minus 2x and then plus 2. So is that one exactly? Yes. Let me change the color. Purple. Okay, so you see, if I ignore this, what has happened? This is the black one. I have moved it 2 units to the right and 3 units upward, and this is the purple one. So what I did is correct. Any questions? Okay, so this is something that I also want you to know about it. But there is a very good problem in the book. I want to talk about that, extremely useful problem. This problem is a nice problem. Let us try to understand the content. So OSA wants to have, I don't know, sometimes like a garden, okay? She has only 16 meters of these fences, okay? You see, she has, in total, she has 16 meters of these kinds of fences. And she wants to make a garden so that one side of this garden, or a small garden, whatever you want to call them, it is close to the wall. It doesn't need any fences. But the 3 sides need a fence. So let me ask you a question. If you want to do this, what do you prefer to do? Let us say that you really have 16 meters of fences. Your money is finished. You don't have more money in your pocket to buy more fences, because of course if you buy bigger fence, you can cover more area. But this is extremely important problem in mathematics. This is called optimization. Optimization, it means that you have a limited resources. You want to do it in a way, in an optimal way. So I don't want, of course, if I can go buy more fences, I can definitely cover more area with the fence. But then I have to pay more. But let us say I don't have even 1 single crown left. I have 16 meters of fence. And using that material that I have right now, I want to cover as big area as possible, which is reasonable, because if you want to have a garden, you want to prefer to have the bigger area covered. I don't raise your hand right now, because I want everyone feels. These kinds of problems are called optimizations. Optimizations is not always increasing. Sometimes optimization means minimizing. Sometimes optimization means maximizing. For example, if you have a factory, you want to minimize the loss. That is optimization. Or you want to maximize the profit. That is optimization. So optimization, this is why it's a good name. We don't say maximize or minimize. Sometimes optimize means minimize. Sometimes optimize means maximize, depending on the context. So in this case, optimize means what? Maximize, because we want to maximize the area covered. And I want you to understand, it is not a trivial problem. So for example, you cannot come up with testing ideas. Let us do this. No, it doesn't work. Let me change it. You want to really, if you are an engineer, by the way, these data analyst people, which is employed by companies, they are more or less doing something like that. They look at the data and then try to consult the owner how to do things to get more profit without spending more money. That is extremely important, and this is a very good question because it's a very practical question. So you are solving a problem in the everyday life. And now, these kinds of problems you study in Math 3C and Math 4, because you cannot solve all of these types of problems, you need the notion of derivative. But at this level, because of what we learned, we can solve this problem. But I want you to understand, let me explain it for you. First of all, if I don't care about optimization, in how many ways I can make my garden? I have 16, so let us have a top view of the garden. So this is the wall, and I want to have a fence around my garden. I know something. I know the total length is supposed to be 16 meters. But how many gardens you can perceive here? Imagine. Infinitely many. For example, I can make them I'm not talking about beauty or something. You can make it stupidly narrow and long so that the total length is 16. Or you make it the other extreme. You can make this kind of garden so that the total one is still 16. So, but then you can say something in the medium, in the middle. But I hope that at least you agree with me, there are infinitely many possibilities in front of me. I want to choose the one with the maximum area. And that one is one, only one, among infinitely many of the choices that I have. Only one of them covers the maximum area, and I want to know how to do that. Okay, so let us solve the problem together here. So the first thing that you should do, you need to draw a rough picture for yourself to understand the problem. If I do it here, I call this one, say for example, this is the y coordinate, let me call it y. If this is y, this is also y, yes? And this one, let me call it x. Do I know what is x, what is y? Not yet, but I know something. What do I know about x and y? Yes? No, they use this information. There is a reason this information is given. I don't know how I built my garden. Yes? 2y plus x is equal to 16. For some reason, if you don't, yes, you are right. But if you don't mind, let me change this letter to x. It's a little bit unusual, but don't worry about that. Can you change it now? 2x plus y is equal to 16. Okay. But this is what I know. But this is not my target function. My target function is my area. I want to increase it. So let me write the area. What is the area of this? What is the area of the garden? X times y. Yes or no? Okay.
By the way, why did you name the two sides the same letter?
No, they have to be the same. No, according to this, it should be a rectangle. Yes? It is mentioned that it's a rectangle. Yes. Okay. You might make it as a circle, you win. That's also possible. But according to the problem, that's a good question. You might say, yeah, okay, I don't want, it's even more artistic, more beautiful, yes? But let us say that, okay, we want to make a crude model. So that's why I'm saying, this you can solve in Math 3C. The reason you cannot solve it now, because I will tell you why. Okay, so this is the target function. I want to maximize this. But this has nothing to do with this lesson unless you realize that from here you can calculate y, which is 16 minus 2x, and put it here. So the area becomes what? X times, instead of y, I put this. And let us multiply that. So a becomes minus 2x squared plus 16x. This is the area. What type of function is my area? quadratic function. So this is why it is related to today's lesson and these lessons that we are studying. Because this is a quadratic function, and what do I want to do here? I want to maximize it. Is it sensible? Do you think that this function has a maximum or a minimum? Maximum, because this number is negative. So everything is in order. So you see, they have asked you a question which is completely a practical question. It can happen in your life. But when you want to answer it, you come up with maximizing a quadratic function. Yes? So if I ask you maximize the quadratic function, you should hopefully know. What should I do now?
Complete a square.
Complete the square. Exactly. So what I do you remember? So A is equal to, because this is one of those hard problems, I factor a minus 2 out. So it becomes minus 2. And then it becomes x squared minus 16, minus 8x. And then I leave an empty space. I need to add a number here to complete the square. What that number is? What?
Plus 16.
Plus 16. But 16 is not there, so I have to take it off as well. I'm just following the same rule. And then it becomes minus 2. These 3 becomes what? X minus 4 to power 2 minus 16. And then I multiply minus 2 in. So it becomes positive 32, negative 2x minus 4 to the power of 2. Okay? This is smaller than what? 32. Yes? Yes or no?
Yes.
Yes, because this is positive. Because of this negative sign, 32 minus a positive number goes below 32. So what is A maximum? 32 meters squared. So the maximum garden that I can have is 32 square meters. Okay? But what is the question? The question is, yes, they have asked you about how big is the maximum area. But to be honest, this is not that much relevant. You don't care what is the max. It is good to know that you cannot go beyond. So what does it mean? It means that if this is not enough for you, then you have to open your pocket. Because if 32 square meters is a good size for you, you have what you need. But if you really want to go beyond 32, don't kill yourself. Instead of killing yourself, you have to open your pocket, because you have to buy more fences. But how can I achieve the maximum potential I have? This is a different question. Unfortunately, I don't know why they haven't asked. They have asked only about the maximum area. The answer is finished, 32 square meters. But you want to know what to do to reach to 32 square meters. It means, how should I arrange my fence? Which x is responsible to reaching to getting me here? Which x?
4.
4. So it means that x should be 4. If I choose x to be 4, then I achieve the maximum level. So if x is 4, what happens for y? 2 times 4, 8, plus y is 16. So x should be 4, y should be 8. So then it is clear. If I want to have the maximum area, it is very interesting. So I have to use 4 meters here, 4 meters there, 8 meters here. In total, I have 16 meters, and the area is 32, and this shows me that I cannot go beyond 32. So you see, it was a very nice, very good problem. Yes?
Isn't the maximum area always a square?
What?
Isn't the square, doesn't the square always have?
No, it shows no. You know why? The reason is that because one side is not covered by the fence. But you are right. If it is going to be four-sided object, then it has to be a square. Yes, I know what you are thinking about, because there is a famous rule. If I have a quadrilateral with a fixed omkrets, the square has the biggest area.
But then there is.
No, because this is three-sided. This is not a quadrilateral.
Why doesn't
Yes, but first of all, I hope that you understand the calculations. Yes, everyone happy with this? Do you understand what's going on? I don't know what is the level of this question. I would consider it a level 3, but I don't know. No, they consider it level 2. But I mean, this I will go and solve some of them for you on Friday. But that is also a very important question. At least this question is good because this really can happen in your life. So, and then it is completely related to maximizing and minimizing a quadratic function. Now, the reason that you cannot solve other problems using this, because I was lucky, the problem was designed in a way that the target function became a quadratic function, which I know how to find the maximum and minimum. Many other problems, you end up with a function which is not quadratic function, but still the question makes sense. How can I maximize and minimize this type of function that we haven't studied so far? All of them will go under the title of the derivative. So we will develop something called derivative next year, and using that trick, we can, in principle, find all possible maximum and minimums for any other type of functions. But for you, Math 2C, whenever you see optimization problems, this means that your target function eventually ends up with a quadratic function, because except for that you don't know what to do. So if you face an optimization problem in Math 2C level, it means that if you do your calculations right, you will end up with a function which is quadratic only. Okay? I will solve some of these problems for you on Friday as well. Any questions? Okay.